47 looks like a FOIL problem. We have a binomial times a binomial. We've got i's involved, but that's okay. We can still FOIL. 3 times 6 is 18. 3 times minus 9i would be a minus 27i. 4i times 6 would be plus 24i. And 4i times negative 9i would be a negative 36i squared. So now when I go through and simplify everything, I have my 18, I have my two middle terms, which I can combine because they're like terms. And then whenever you see an I squared, we replace that with negative 1. I always equals the square root of negative 1, and when you square that, you get just plain old negative 1. So don't forget about that. Whenever you see I squared, replace it with negative 1. So now I'm going to have 18 minus 3i, and a negative 36 times a negative 1 would be a positive 36. And now I can combine 18 and 36 because they're both numbers, and I'm going to get 54 minus 3i. And you can always check that by putting it into your calculator. Remember, I is a secondary function on the decimal point, and as long as your calculator is in the mode a plus bi instead of real, then it will calculate this for you, so it's a good way to check your answer. 49, we still are working with I. And we need to get I out of the denominator because it is a square root. We can't have a square root in a denominator of a fraction. So I'm going to multiply by the conjugate. Because multiplying by the conjugate will eliminate my i's in my denominator. And again, I'm still technically multiplying by 1 because I have the same thing top and bottom. So I'm just doing a rewrite. I'm not changing the value. I'm just finding an equivalent fraction. So I'm going to leave this as negative 4 times 5 plus 8i for now. I might distribute that later on, but I'm going to wait and see. I might be able to do some canceling. And then when I FOIL my denominator, I get 25. I get plus 40i minus 40i, which is what we wanted to happen, and minus 64i squared. So then, I still have my numerator, negative 4, 5 plus 8i. My denominators, let's see here, I can cancel my two middle terms. So that's going to leave me 25 minus 64 instead of I squared. I'm going to put in a negative 1. So see how we no longer have an I in the denominator? It will end up being just a single number as soon as I'm done simplifying. So now I have negative 4 times 5 plus 8i all over, that would be 25 plus 64, because a negative 64 times a negative 1. And that's going to give me negative 4 times 5 plus 8i all over 25 and 64. So here would be 9. Looks like 89. And now, because it needs to be an a plus bi form, I'm pretty much done. That's my answer. But now I need to write it in the proper form. So I'm going to go ahead and distribute my negative 4, which is going to get me negative 20 minus 32i all over 89. And a plus bi form, we have to have it in two separate fractions. So negative 20 over 89 minus 32 over 89i. And that's my final answer. 51, we're shifting gears a little bit, getting away from the radicals and the I, and we're moving into quadratics. Now this quadratic we are unable to solve by factoring because it's not going to factor. We're not going to be able to find factors of 1 that add up to 6, or if you do the box method, it'd be factors of 6 that add up to be 6. We don't have any of that, so it's not going to factor, but we can solve it by using the quadratic formula. Recall that the quadratic formula is x equals negative b, so x equals negative b plus minus the square root of b squared minus 4 times a times c all over 2a. So in my problem, I've got a would be 6, b is also 6, and c is 1. They're all positive. So now let's plug them in. So I'm going to get x equals negative 6 plus minus 6 squared minus 4 times 6 times 1 all over 2 times 6. So now I just have to simplify a number crunch. So it's going to be 36 minus 4 times 6 times 1, so that's 24 all over 12. So negative 6 plus minus the square root, 36 minus 12, or 24 is 12, all over 12. So I'm pretty much, that's my answer. Now I need to simplify it, because the square root of 12 will break down into 2 square root 3 all over 12. So if you don't remember how that 12 breaks down, the square root of 12, if you break it down into its prime factorization, ends up being 2 times 2 times 3. So I can ring up a 2, which means then I would have 2 square root 3. So in case you didn't remember that, now all 3 of my terms actually have a 2 in common, my 6, my 2, and my 12. So I can factor a 2 out of everything, which is going to leave me negative 3 plus minus square root 3 all over 6. And that is going to be my final answer, negative 3 plus or minus square root of 3 all over 6. And you can leave it in this form. If you want to rewrite it as 2 separate answers, you can, but I would accept negative 3 plus minus square root 3 over 6. Number 53 is, they give you 2 points and they want you to find the distance. So if you have to use the distance formula, which is on your formula sheet. And it pretty much just says subtract your x's and square it, and then you subtract your y's and square it, and then you add those 2 quantities together. So if you were to graph these 2 ordered pairs on a coordinate plane and you wanted to know the distance, this is going to be the way that you're going to calculate it. This is actually a form of the Pythagorean theorem. That's where it's derived from. Don't forget this big square root. So if I plug in my x's, I have a 3 and a negative 4. So I'm just going to say negative 4 minus 3. And it doesn't matter what order you subtract in, because in the end you square it. So it doesn't matter if it's positive or negative. When you square it, it's going to come out positive. And then when I subtract my y's, I have a negative 3 and a 2, so I'm just going to say negative 3 minus 2. Square that. So now I have negative 4, negative 3, that's negative 7 squared. Negative 3, negative 2, that's negative 5 squared. So distance is, this would be 49 plus 25. So distance is going to be square root of 74. Now, it may ask for, this one does say where appropriate give an approximation. So square root of 74 is approximately 8.602. So there's our exact answer and our approximate answer.